What is up? Randroid here. We are doing another stream. Alright, it's going to be a really fast one. I say that, and then it'll probably drag on, but it's kind of late. I was working all day, so I'm going to just do kind of a quick rehash of last week and how I could have done things much faster. So let's kick it off. We're looking at Bard and Bing. I asked Bing what they like to be called, and they like to be called Bing Chat. So ChatGPT and Bing is Bing Chat. All right, well, let's get started. So what did I ask? I basically asked the question that I asked at the end of last stream, which was, hey, we were doing this code kata. It's a bowling score, kind of famous code kata. I talked a bit about it last week, but I tried to do it on my own, but I just asked both Bard and Bing how to write that test or write that score with tests, and it just outputted everything for me. Now, we tested last week. The one from Bing definitely worked, but I asked it again today and got a slightly different answer. So it just shows you how you don't always get the exact same code. But the Bard one is just wrong from what I can see. So let's look at like what Bard is suggesting here. So if we go to the tests, they're saying if you get a strike, then you should expect 10 points. That's just not correct. So strikes will give you a bonus. So a better example would be how Bing did it. They also have a test for strikes. They have one strike test. So the way they're doing it might be a little hard to read, and I would improve this slightly, but they roll a strike, then they roll a 3, then they roll a 4. Now, why do they roll 2 more times? Well, because you get a bonus of the next 2 rolls. And then they went ahead and rolled 16 times with gutter balls. So why do they do that? Well, every one of these tests is testing this final score, so all 21 possible rolls. So in this case, this counted as one roll, and it's only adds up to 20. So 1, 2, 3 plus 16. Actually, not even 20. The reason why it's 19 is because they don't get a bonus on the 10th. I'm overcomplicating, but the point is they rolled 19 times, and the last 16 were gutter balls, so you don't have to factor those into the score. So the total final score was 24. How do I know that's correct? Where would 24 come from? Well, you know they rolled a 3 and a 4, so that'd be 7, plus 10 for the strike, 17, and then the bonus would be plus 3 plus 4 equaling 24. So remember, they don't just get the 7 for rolling 7, they get a bonus of 7 for the strike that they got previously. So it sounds complicated, but it's just complicated enough to be a good exercise, really. So we know that Bard is wrong here. I asked them I told them they were wrong. I said the code the code you provided does not give you a bonus for strikes. I didn't tell them about their spares. Spares were also broken. And what they gave me back had the same problem, I think. Let's see, test strike, or a different problem, I guess. They rolled a 1, then a 10, and then a minus 1. And they said you get 30. So that, I don't know where they're getting 30 from. We expected, I guess maybe it's 10 plus, I don't know where they got 30. Would have been multiple strikes. So it's just wrong. So it doesn't know what it's doing. But let's also look at how Bing tested this. So Bing kind of tested this in sort of a TD manner, in that their first test is a gutter game. So just that you can roll 20 times proves that part of the features work, right? And then you could add on more scoring. You could add on scoring by actually rolling 21s. So if you only knock down one pin 20 times, you get a score of 20. To test a spare, you just kind of like the strike, you knock down 10 pins, but you do it in 2 rolls, so that's 10. And you only get a bonus of the 1 roll, the following roll instead of 2. So that'd be 10 plus 3 plus 3, which would be 16, which is correct. And then a strike, and then finally they test a perfect game. So you may know perfect game in bowling is 300. Kind of a weird number, but that's what it is. If you roll 12 strikes, you get 300. Why 12 strikes? Well, it's 1 roll for the first 9. The 10th one is on the 10th frame. That's going to give you another roll, the 11th one, and if you get that one as well, you get another one. So equals 21 total possible rolls. If you get all strikes, it comes out to 12 total. And with the way the bonuses work, it comes out to 300. Now, what tripped me up last week is not realizing that you don't actually get a bonus for the last 2 rolls. So if you get a perfect game, on frame 10 you're going to have a 10, 10, and 10. So you get a bonus for the first 10, I believe, right? Because you take the next 2 frames, and we have 2 more frames. So it's 10 plus 10 plus 10. So it's 30 for the first roll in the 10th frame. But the second frame the second roll in the 10th frame is only 10. Why is that? Because it can't there's not going to be 2 more rolls. And I thought maybe it would just give you, the 1 roll you have left. It does not. So no bonuses for the last 2 rolls. And so what's cool about these tests and about the way the code is written, and that's why I really like this exercise, is that there's nowhere in there that really explains that confusing scoring thing. And that's because it's always looking for the next 2 rolls. And if it doesn't have 2 rolls, it just doesn't give you a bonus. And so the only special rule would be that you get an extra roll on the 10th frame. So if we can find that code, let's see if we can find that code. Let's see. So I went ahead and moved this over to IntelliJ, and you could see the bowling game code here. And you can see that I have a breakpoint where it's calculating the score for a perfect game. And notice there's 21 possible rolls, but it only actually filled in the first 12, starting at 0. And when it's calculating, all these are strikes, so it adds a 10 plus the strike bonus. In this case, the strike bonus is the next frame and the frame after that. So they go by frame index here. Cool. So where's the 10th frame magic happening? Let's see if we can find it. So the first time around, it gives you 30 for the first strike, which is correct. I guess the magic would be less on the scoring side, which is kind of the point I was trying to make, is that it's not special logic for scoring the 10th frame. It's special logic for getting an extra roll. So really, I should have set a breakpoint when I was doing the rolls. So let's see. I have a feeling that this might not really enforce the rule. Let's see how it works. Alright, so if I roll a perfect game, you know what? I have a feeling it doesn't actually cover this case. So if I run perfect game, but I decide I want 13 rolls, you really shouldn't be able to have 13 rolls. And if you remember last week when I was trying to TDD this, I actually... Oh, it did stop. Great. I was debating whether or not to throw an error or somehow finish the game after the final roll. So this is actually still working somehow, which is very curious. So let's run it again with debug. Alright, so if we check, we still only have 12 rolls. So something is stopping it, even though I told it... No, that's not true. We have more than 12 rolls. So it's only going to calculate 12 rolls. Why? Ah, here we go. So this only calculates the 10 frames. So this is one thing Bard did differently as well. It's one thing I originally was doing differently. I was using frames instead of rolls as the kind of the source of truth, and it made things more complicated, and you can see that in Bard's code as well. But if you use rolls, you can then convert to frames when doing the scoring. So they're doing that here. The question still, though, is how do they add up that extra frame, that extra roll on the 10th frame? Well, let's see if we can figure it out. So when it's going through the first time, now the index is 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So it stopped at like 9 because this only goes to 9. So we know that's working. But how did it get that last ball? Okay, so this is 8. Let's look at the strike bonus. So I think what's happening is it's giving you the bonus for the last frame. So you rolled a strike, so you got 10. Then it's giving a bonus, which is your next, if we look at this code here. So check this out. It's giving me, if I were to calculate what roll this is, that's another 10 for the second roll in the 10th frame, and another 10. So it's just adding those up as if they were bonuses. So you don't really need any fancy logic. You just have to calculate it, the 10 frames with the same logic, and it works magically. Cool. Okay. Interesting. Well, one thing I wanted to kind of do was experiment with how much faster I could write this, because the kata is about practicing the skill, practicing the craft, repeating the same steps, and see how much faster you can get. But I think before I start from scratch, I was hoping let's try one where we keep the tests that we know work. And so this is an idea I was thinking about, of having AI help you with just writing the test and then you implement the code. So if we keep this test and then completely implement TDD one test at a time. So if I comment out all the other tests, we start with the gutter game. So before I delete it, it's going to pass. Cool. So this is just some extra practice to get really good at this kata. If I delete bowling game, or let's go one step, let's say we have the bowling game class, but nothing in it. All right, I don't have a score function. So now we are at a failing test. So let's see how fast we can TDD this. All right, so I'm going to say I want to have a score. I'm going to, yeah, it actually suggested there, that little suggestion was from ChatGPT, from Copilot. So I'm going to suggest we start with returning a score of 20. And the test is now going to fail for a different reason. Not because it can't compile, but because we expected, what did we expect? Well, actually, that's correct. We expected zeros. So this would have passed, but we failed for a different compiler error, which is my test code is trying to roll. It's trying to roll how many ever times I told it to roll, so a full game. And there's no such thing as called roll, so we're going to go ahead and create that function now. So this is how many pins we wanted to roll. So let's say we do nothing. We just roll them. This should still work. This should work. So now the function exists. It doesn't do anything, but it exists. So technically, a gutter game could work if you didn't write down any pins that were or any rolls or any pins are knocked down because everything you rolled was a 0. So it just kind of works, right? So let's move on to the next test. And it's cool that we're doing it this way. I can show you the power of TDD. All right, so I want to test I got all ones. Okay, so this is the test that drives me to change the code to actually keep track of what pins got knocked out, because I got a 0 when I expected a score of 20. So how do we fix that? Well, simple. Instead of having score always return this, we could, there's a couple of different ways we could quickly get it to pass, but we could write down, so the dumbest thing we could do is connect this, the roll to the scores. So we could actually, if this was equals 0, and we could just do score plus equal pins. I have to make it variable. Alright, so that's the naive solution, right? Let's go with the naive solution until we find a reason to make it more complicated. So both tests are still passing. Okay, fine. Let's get something a little more complicated. Alright, spares. So now I'm going to say roll a spare, which is just 2 5s, and then a 3, and then zeros, and I expect 16. Well, what are we getting now? So we're not going to get the spare bonus. We're missing the 3 for the bonus. Okay, well, what's the simplest way to add the bonus? Let's go to our bowling game. Well, we're going to have to, this is where we're going to have to start keeping track of rolls, because you can't possibly add a bonus of the next pin when you're constantly adding the pins to the score, because you don't know what the next pin's going to be. So this way no longer works. So instead, let's introduce an extra layer here where we record all the rolls. So we'll call it rolls int 21. So it actually knows what I want here. So I want int 21 because, like I said before, there's 21 possible rolls. All right, which is basically what happens if you spare the entire game. You would get 21 rolls. All right, we want this. They can all start out as 0. It doesn't really matter. And then instead of setting the score here, we're going to say rolls. It already knows. Score plus plus equals pins. Is that what we want? That is not actually what we want. We can change this though. We want a running index. So maybe we say val, or we'll say var current roll equals 0. Go with current roll instead of score. I think you got confused because score was also initialized to 0. All right, we're doing the plus plus because, which is postfix, so that it will be 0 and then it will change to 1, but only after accessing this index and setting its pin. A better way, or another way to write this that might be clear for some newer people would be to introduce a variable here, and we'll call it the index. And if you really wanted to, you could do this, and then you could say current roll equals current roll plus 1. So that's a long way of writing it, and it's going to say, hey, you can actually do this quicker if you do plus equals. So all the 3 of those ways are ways that you can increment the current roll. And this is saying it could be private. Let's go ahead and make it private. Same with rolls. Cool. All right, but this is now returning 0, so our test would fail. We don't want to return 0. We want to return get, and we'll just calculate it as, so this wants to suggest a bunch of code, but we actually don't want to do all this yet. We just want to do rolls dot, so there's some functional stuff you can do. You can actually like loop through each one of these, so like a simple loop would be like for each, and you could just say like score plus equal to it, where it is the score in the roll. But there's actually something you can do called dot sum, and that should sum up all the rolls for us. Oops, I messed this up. What is the syntax I'm looking for? What did we have earlier? Cool thing, you can look at your history. Where's our history? Local history. So earlier we had a get that was just fine. Oh, it's my bad. I don't usually use this syntax. So it's actually get equals. Cool. Oh, nope, didn't like it. What part? Why is it mad? Let's see what happens here. Alright, so the only one failing is this one, because we didn't actually do, so all that we were just doing was refactoring. Actually, to get the bonus, we need to add in some logic. We can't just sum up all the rolls. It's kind of what it was doing before. But now that we have the rolls separately, we can introduce some extra logic for calculating spares. So we could say dots could go when. Yeah, I guess we'll do for each on the rolls, like I said earlier. But we'll do a when on its, and we'll say when I want to say is spare. All right, so it's trying to help me out here. In an else case. Okay, we need a function where we pass number of pins to a function called isSpare. So we create a function called isSpare. We return Boolean. Okay, and then we say, oh, in this case, how do we know if it's a spare? Well, we don't want the number of pins. That's actually not correct. I think we need to do the whole index thing. So let me try changing this one more time. All right, get return 10. Why is this not happy? Hold on, let me see how they did it. All right, so they used a function, and I actually asked him to change it to a property syntax, because Function's probably easier for me, but I want to practice this. Okay, so get, there's no equals. Okay, thank you. All right, let's try this again. So, first off, do we need the index now? Seems like we might. Well, I don't want to jump too far ahead, but we know we're also going to need the concept of frames at some point. What if we did the for loop for 0 until 9? That's not the right syntax. What is it? Oh, frame in 0. Frame in 0, 9. So this is some interesting Kotlin syntax. It's filling in these less than or equal to signs. These aren't actually here in the code. The dot 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 is though. So this is saying loop from 0 to 9, where each number, so the first one is 0, 1, 2, 3, 4, whatever, will be set to frame. So first time through frame equals 0. Okay, and then we want to, I guess we need a local like score. So if we say var score equals 0 outside of the loop, sorry. And we say score plus, yeah, so it's trying to add equals roles frame times 2. I don't know about that. So if we just started with this, does this give us, not our bonus, but does this give us working tests, our other 2 tests? No. All ones broke. All right, so that makes sense because now we're only looping the first 10 roles. We actually need 20 in the case of rolling 21s. So now this is going to introduce the frame index bit. Okay, so so it's going to be both frames when it's not a strike. So we could say this plus rolls frame plus 1. Let's see how that works. Great, and we're back to working. So how do we get that spare for bonus? Well, this is the regular roll. We want to check if it's a spare. We want to do something different. So when what? When we want to check when the current frame is a strike. Is that how we did it? I'm gonna have to take a look. Oh, there's no. Oh, there's a when. But it's just no. Okay. Cool. This is better. So if we say when is spare, and we pass it the frame. Let's see, let it autocomplete there. Else, let's see if this is correct. So if it's a spare, you're going to give 10 plus the bonus, which looks correct because remember, bonuses is the first roll in your next frame. So in this case, the next frame is going to be 2 rolls away because we're starting at the beginning of the frame, and you rolled twice in the frame. Cool, I think that's correct. Is spare frame, and then we want it to actually return. What we could do is we could return the score here. Might be better. Oh, problem is the frame is not actually a frame. Well, we probably want to. Do they pass in the rolls? They pass in the frame index, which is not the same thing as the frame. Score plus equals. Is spare. Let's look at is spare. So it takes the frame index, and then it has access to all the roles probably. Let's find out. Yeah, it has access to all the roles. Okay. So, but it does actually return this. Oh no, it just checks if it's equal to 10. Okay. Well, let's do the same then. Let's return. I guess we'll do the frame index. I don't know. Alright, we'll pass the frame index instead, and then once you have the frame, we'll call this frame index frame index. You want to return a boolean because you're just asking, was this frame a spare? Okay, so return roles frame index plus frame index plus 1 equals 10. Right. So that should give you, if both roles in that frame added up to 10. Alright. And then in this case, we want to calculate a bonus. So I think just doing roles frame plus 2 works for now, but we may want to revisit that once we have someone forcing us, once there's a reason to do it. Alright, let's run our tests. Alright, still failing. We got 103. Okay, so something went wrong there. Oh, we're not increasing frame index. So remember the whole plus business that we were doing before? So we can go ahead and say frame index plus equals 2, because you rolled, if you're a spare, then you must have rolled twice. Cannot be reassigned. Let's make it var. And then what about this case where it wasn't a spare? Probably it's not going to be a strike. It's going to be the same thing, I believe. So let's do this. Okay. All right, closer. Actual 24. So what could be happening here? Let's look at our tests. It's rolling a spare, so 5 and a 5, and then a bunch of zeros. So this is going to be 10 plus the bonus one, supposedly, and then for the remainder of the frames, it's going to be just the frames. These should be. Thinking these should be frame. Should these be frame indexes? What's the point of using frame and frame index here? Let's see. So they do a strike frame score plus equals frame index plus plus. Oh, they only add one frame. What about if it's a spare? Okay, they add 2 if it's a spare. That makes sense. They add 2 if it's not. So that's all correct. But where did they use frame? They do not use frame here. Yeah, it seems they don't use frame. They just use it for looping. Interesting. Well, we can do the same. Okay, that did the trick. Well, let's look at the next test. So now we're testing one strike. So we'll run it and it should fail. Sure enough, it's only 17. We expected 24 because we were supposed to get an extra 4. That's still, oh, we were supposed to get extra 7, so 3 and 4. You would think it would just give you the 3, but remember that logic is only for spares. It's going to think it's a normal frame because it doesn't know what a strike is. It's not a spare, so what is it? And actually, why is it not a strike? Because you would think that this is spare logic. It adds up a 10 plus a 0 should have been a 10. Yeah, that surprises me. I would have thought I would have hit this. Let's do some debugging. Never made it inside its spare. Even though... Let's try again. So here, it has a 10, and this one's a 3. Which adds up to 13. Aha. That's how it knows it's not a strike, because it must not be all in the same frame if it's more than 10, because the max you can get in one frame is 10. So taking 10 and 3, so this frame and then the first roll of the next frame is actually more than 10. So you know it can't be it can't be a strike. Cool, that's very cool. Didn't realize it would do that for us, but it does. Alright, so we know we need the is strike logic next, so let's go ahead and add that. Alright, frame index in business. And then this is same thing. We need a new function, so we'll add a new function here. We don't want it to return any, we want it to return Boolean, so I'll change that. And the logic should be similar, except as it's trying to help me out here, rolls frame index equals 10. So just the first one. So if it is 10 on that roll, then we know it is a strike, so we want our score to be 10. And then the bonus, which is the next 2 rolls, rolls frame index 1 plus rolls frame index 2. Okay. And now it's saying we only add 1 to the frame index because we only rolled 1. Alright, I think that is correct. Let's run it without debug though. They all pass. Alright, let's check. Our next test would be a perfect game. And it just works. So this is kind of the magic I was hoping to show the first time we did this kata, and that's that this test is not even really test driven, because everything you wrote up to this point, how to handle ones, how to handle, which are like open frames, how to handle spares, and how to handle strikes, actually covers the entire game. Which is pretty cool. So these are actually fairly good tests. So much faster this time, obviously with some help, but we could probably even do it in a fraction of the time if we did it one more time. So let's try. All right, speed mode. Okay, we need a score. All right, I know this thing is going to be a get. I'm going to say it's equal to 0. That's fine. We need a roll. Okay, I'm going to create a roll. Int. All right, so I'm just going to say 0 for now. Cool. Run this guy. It works. Next, we want to test all ones. That will fail. We got 0. We wanted 20. So we're going to check the score. And here we decide we want to write down the rolls. Let's say we want to do, yeah, let's write down the rolls. So val actually rolls equals int array 21. Okay, so we want to say rolls, and we don't know what our index is, so we need an index called var current roll equals 0. So we go current roll, and we can go ahead and plus it equals pins. Cool. We'll run all that again. Alright, it doesn't do anything in the score with it yet. So now we can add up, here we could say when, we'll go else, and we'll say val score equals turn score. So, oh, can't return. I don't remember this part of the syntax. Let's try 10. Doesn't like it. So we know we need a var score equals 0, score equals 10, turn score. That's what I had. Okay. Couldn't I have done this then? Equals this, and then you just say 10. Right? And then this is saying this can be val now. And what if I just return this? Then I don't need this. Unreachable code. Okay, so but we don't want 10. We want to add up the rolls. So we do we need to do the loop. We are missing the loop. Well, I guess we could do the sum first. Rolls dot sum, and see if that passes. Sure enough, all ones works. All right, so let's see if we can get some spare logic in here. So spares is going to come up a little short without the bonus. It's going to be 13. We wanted 16 because we rolled an extra 3. We'll go ahead and add some logic here saying is spare. And in this case, we want to pass in the frame index. And so if it is a spare, then it's going to be 10 plus the rolls and frame index plus 2. Okay, cool. But what is the frame index? We don't have frame index, so we'll start off var frame index equals 0. And then we still are missing the do this 10 times business. So now we need the loop. So we'll go for frame in 1 dot dot 9. Oops. Okay. And we need the spare. Takes the frame index, returns a boolean, and it goes through the rolls. We'll say return rolls index frame plus frame 1 equals 10. Right. Just give an extra curly here. This guy is not very happy. Why? Okay, so we are missing the return. So I think we need the score. So let's go ahead and say var score equals 0. And instead of return, let's just say score plus equals. And then we can return. Okay, now he's happy. But we are not upping the frame index. So remember, for spares, we need frame index plus equals 2. In fact, we need that for non-spares as well. And so now we can no longer return the score like this. So it's kind of a weird syntax anyways. So we'll go ahead and say score equals this. But this is not going to work because now we are summing up, and we don't want to sum up. When it's not a spare, we want what? We have rolls, frame index plus rolls, frame index plus 1. Is that correct? Run all the tests. And test all ones failed. So this came out to 18, we wanted 20. Well, let's see if I messed this up. Well, the score should have been the roll 0 plus roll 1. That actually looks correct to me. So where do we drop the 2? This, they're saying we can make private, so let's go ahead and do that. Did we... yes, this should start at roll 0. First rule of programming. 0 indexes. Cool. Alright, back to the test. Now we've got ourselves the test 1 strike scenario. So as we know, this is actually the last bit of code we need. So we could say is strike frame index score plus equals 10 for rolling a strike plus some bonuses. So rolls frame index plus 1 for the next roll plus the bonus from the roll after that. So you get 2 bonuses. And then the frame index only goes up by 1 this time. And then how do you know something's a strike? Well, we write a little function for that. We return a boolean. And we say return rolls frame index is equal to 10. We run our test. The strike now passes, everything passes. Yay. And we can go ahead and uncomment our last test just to prove that a perfect game would work. Awesome. A little refactoring we can do. So let's try refactor the real code. So go to the bowling game. These could be written slightly differently. So convert to member extension. No, that's not what we want. We give you put the cursor here and you say convert to expression body. There we go. Just a little easier to read. What else could we tweak? I think all this is fine. These are private. Okay. What about our test? So roll many and then assert. Roll many and then assert. And these are good enough. Cool. All right. So you saw how much faster it was the next time around, right? So that's one thing a kata gets you, is it gets you practicing some of the basics of the language, and moving quickly through exercises like this will create muscle memory, right? And you saw as I was doing it, it was giving me some hints because I have Copilot turned on. For some reason, this plugin doesn't really work anymore. At least, let me see if I can get it to autocomplete. So it wants to autocomplete here, but the little plugin, okay, it does come up. Great. Versus the plugin we have in Visual Studio Code, which is much smarter. Okay, well, let's call it there, and I'm interested in see what you want to learn next in programming or AI or anything like that. Worst case scenario, we'll try a different kata next week, but happy to hear what the audience wants to see. Anyways, thank you for watching. Really appreciate it. Have a good week.